Our old website had this nice animated feature on the side we called feature navigation. It looks nice and smooth running on the powerful computer I develop on, but how does it perform on a computer that doesn't run as fast? If we open Chrome's developer tools and go to the Performance tab, we can simulate a CPU slowdown and find out. Not nearly as smooth. We can also use the Performance tab to help us find some of the performance problems. After making sure we are in incognito mode so that browser plugins don't interfere with our test, we can hit the record button and start profiling our app. When we're done profiling, Chrome shows us the results, including hardware utilization and frame rate graphs, as well as network, interaction, and scripting breakdowns. Let's zoom in on a single frame and see what's going on. Wow, there's a lot of code being executed for one frame. It looks like most of the time is spent running the React set state function in the onScroll callback function of our arrowdown.js file. If we look at the code, we see that we're controlling the opacity of our arrowdown component using a state variable. While state variables are great for dynamically updating the content of our app, it adds a lot of overhead if we're setting it on every frame. Instead, we should directly modify the CSS style of our element. Let's run another profile and see how the performance changes. That's much better. We're doing a lot less work per frame, but we can still make some more improvements. In this frame, we see a number of purple elements on the timeline. These represent styling processes, like layout or style recalculation. Since we're only generating one frame, we should only have to reprocess the styles once. What's causing Chrome to reprocess so many times? We're running into an issue called forced synchronous layout. The problem arises when reading the styles of elements and then writing to the styles of elements multiple times in a single frame. As soon as we change the style on any element, the next time we try to read the style of an element, Chrome has to reprocess all the styles to give us accurate information. Clicking on the event can give us more information. Here, in the summary for this event, the recalculation forced entry tells us what line of code is causing Chrome to recalculate the styles by reading a style value, and the initiator entry tells us what line of code invalidated the last style calculation by writing a style value. In the code for our feature navigation component, styles are being updated on elements, and later in the code, styles are being read. This is forcing a style recalculation. We can fix this by reading and caching all the values we need at the beginning of the function, so that once we start writing new values, we won't force a recalculation. While this is relatively straightforward for a single component, it can be difficult to synchronize this behavior across multiple components. Here, libraries like FastDOM help by creating universal read and write queues, which lets us easily coordinate reading and writing styles in order across many components. Now, let's run another profile and see the effect. Great! Now, outside of the browser's scroll handler, all our layout read and writes are done together and performed at the end of the frame. While there are still many more improvements we could make, especially with the scroll-linked effect like this one, these are a couple performance issues to keep an eye out for when using the Performance Profiler in the Chrome Developer Tools.